Hello, everyone. This is Olivia from the Customer Enablement team. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is disaster recovery and OCI, or Oracle Cloud Infrastructure, which will cover the key concepts, techniques, and best practices for designing a highly available disaster recovery solution in OCI. And yeah, I'd like to introduce Lynn and myself as the main presenters. And with that, I will hand it over to Lynn to get us started.
Thank you. What we're going to be doing today is talking about the disaster recovery, and we're going to do it in a way that I makes sense to me. First, we're going to talk about what's built into Oracle's data centers and how it's structured that give you high availability and good disaster recovery features. Then we're going to talk about the specifics of a few as an example of some of the things we've done with our products as well. So all the products we have methodologies of improving your disaster recovery and being highly resilient as well. And then we're going to talk about some of the standard architectures that are typically employed in such manners, right? So you can have a backup and restore, you can have a standby or a ghost town, and you can have an active approach as well. So sort of a duplication of everything. We're going to briefly touch on a couple of the third parties that we have. I would suggest that if you're interested in there's something that we don't have at Oracle that doesn't suit your needs or that you're using already, that you take a look at our marketplace for our data centers as well, OCI's marketplace. And then we're going to show you probably one of the most important aspects and key to being able to reconstruct is your infrastructure as code. One of the things about all of the hyperscalers is we've all provided tools, many of them standard and industry standard tools that allow you to construct your architecture through software. And then I'm going to do a little bit of advertising at the end for our full stack service, our full stack recovery service as well. So you want to be able to reduce your downtime. You want to minimize any additional infrastructure because you want to keep your costs down, right? And you want to manage your complexity and you want to ensure compliance. It doesn't do you any good to develop your production environment and be compliant there and then fail over and be non-compliant. So it has to be addressed across all your architectures that you put in place. Make sure we're all on the same page with respect to vocabulary. So there's two things you're concerned about. Number one is your data loss, and typically that's the reference there is your recovery point objective. So it's your tolerance for data loss, and all these are business decisions at the end of the day, right? So it determines the frequency of backups and the replication approaches that make sense to meet that data loss objective. Likewise, the amount of downtime that you can afford. And that too will cost you money. So you want to make sure to shorten that to within your business objectives. And that's key to this whole business is that you do have to have business objectives that make sense. And the trade-off between the cost of downtime, the cost of data loss, and the cost of minimizing both in a reliable manner. So one of the aspects that we provide for you is backup and restore, where you back up of on-premise data to OCI to use in a disaster recovery event. And for very little money, you can get yourselves with 24 hours of point of recovery and 24 hours backup. But if you're running a real business, that might be, even if it's internal customers, even if it's talking about your employees, that might not be tolerable. Standby, again, a ghost town, but with certain things already backed up and with many of the environment parts of the environment and architecture pre-built for you. That costs you a little more, and that's sort of a standby. And then you have active, where we're sending data almost simultaneously back and forth, and that's estimated here to be less than 2 hours to get your data, and 2 hours of data loss and 15 minutes of getting back up. And these probably, unless they're global now, are less than this. You can shrink this depending upon the amount of your tolerance for pain, so to speak. It's either pain continuous with the cost of doing it, or it's pain when it actually happens and it works out. And so one of the things that I like to remind folks is that our regional structures, each one of these contain three data centers, right? And in addition to that, the data centers are connected by high speed connections and encrypted. But likewise, within the data center themselves, we have multiple fault domains and we have very dense architecture. Uh, Nowadays, every single bit of fiber has intelligent NIC. So that allows you for this off-box virtualization. So you get the NICs plus the virtualized system, which is usually a router in the rack to control all of that movement and data. And so that's all your physical employment. And then you have the virtual network on a virtualized system so that it minimizes loss and gives you a situation where, for us at least, you don't have any noisy neighbors. So in addition to what I mentioned, the three availability domains, the three full up 5 9 data centers, in each of those data centers, you have three collections of racks that are independent of all the other racks, and right down to power supplies and cooling. So you you could lose a whole data center, though that really has never happened with us, not in the last 7 or 8 years. We have lost the backbone, and it didn't happen just to us, but it was the whole industry got whacked during the plague. But that's another story. But right now, you can, in every one of our data centers, you have three availability, every one of our availability domains, you have three fault domains. So in a single region, you would have 9 fault domains. And I emphasize this to from my history. Uh, Notice the gray hairs. You would be in the situation where, 15 years ago, your data center would be in your back room or your copy machine. And the only reason it was in your copy machine room is because the noise level, OSHA required it to be somewhere where the noise didn't bother the rest of the folks. But now we have real data centers that are professionally run and managed and cooled and off somewhere in the cloud. So it gives us real things to work with. And so these things really aren't that likely to fail. But of course, when they do fail, everything goes. So that's what your risk is. So you can work with this. As mentioned, the regions are completely independent of other regions. You can also mitigate the risk with region-wide events. So that's the idea of having all of them 50 to 80 kilometers apart. And also it meets the legal jurisdictions, tax domains, and other business and social criteria that are required depending upon where you are. And yeah, depending upon where you are. And you connect your regions using remote uh, vir virtual cloud network peering, which we do through our DRGs, and they are very easily set up. So in theory, you can set these things up. You're encrypted from beginning to end, and you can create a single virtualized network that operates from one uh, data center to another pretty cleanly. And with the new standardization with respect to off zero, that's and the industry's writing around Active Directory, in theory, if it's all set up properly, you can log in once at the beginning of the day, use two-factor identification, and then go from site to site, from application to application fairly seamlessly. Again, that depends upon what your security team wants to do. The other thing is, okay, so you got the underlying data center operations. Now, with let's talk about some of the things that we put in our products. With, in particular, from a database perspective, we have our autonomous database, and we like that. It minimizes the errors that are made and puts you in a position that you only have to worry about the things that you can make a difference in, whereas this has complete database automation and complete infrastructure automation. This is an Exadata platform in those situations, which is designed around our software, and our software likewise is designed around it. So we've been working with Sun for a long time. So automated reliability, highly available self-healing architecture, triple mirrored disks for disk failures. There's no disks. There's no disks. There's just different types of flash. Automatic recovery for compute node failures, automatic backups. We put all that put in place for you. Online patching for complete protection. We do this all in the background. We do the Linux underneath, and we do the databases as well. And this is something that we've been working on. We do it all in memory, and it causes no failure or time loss in any way. We've been doing it for 30 years with our Linux. So this is not new technology, it's proven technology. Autonomous Data Guard. Now, this again gives you the ability to enable standby database for each autonomous database instance in just one click, and it's completely automated. I'm not a big UI person, so, but it's there for you. And everything that we can do in the UI, of course, you can do in control line interface as well. And you can, if you're a terminal person, and you can write a program using one of the REST APIs, which are in our SDKs. You can do that with Java or Python or Ruby or Go, so that you can make all this fail over real easy. In addition to that, there's a standard of using Terraform. So we'll talk about that in a minute. So Active Data Guard means you're constantly in a situation of your queries, your reports, or backups, occasional updates, starting with 19C and now, of course, with 23 AI. You have automatic block repair, application continuity across the board as well, and zero data loss at any distance. Think about this like NFS, right? If you remember NFS when it first came out, it was slow. Well, that's because the internet was slow in those days. We didn't have 10 gigabit connections or higher between data centers or to your house. So NFS sends a packet and it doesn't lock it in until you get confirmation, a handshake between the two. So that's basically what happens here with our data guard as well. It for zero data loss, you get a handshake that yes, I did receive it. Yes, I did get it. Now I can move on. So gives you a lot of capability. Another thing that we put in place for your applications is, of course, you're running either on a boot volume or a block volume for your data store with respect to your virtual machine or your other compute source, bare metal for that matter, or for your containers. And so you can group these and then you can do group backups. So you can perform most of your same backup operations, restore volume group backup to a volume group. You can do everything. And again, yes, you can set this all up in the UI, take a picture of it with respect to your Terraform state file, and then recreate it as many times as you want to. And different regions, different connections, however you want to put that together with a minor edit of a few lines of Terraform code. So, and we of course allow for easy migration and across regions as well. So it doesn't matter uh, where you want to put this in the world. Well, if you're moving from New York to Frankfurt and from Frankfurt to Australia, it's going to take a little longer, but we can work with you on that as well. So here's some of the architectures, right? So we've talked about the basics of the underlying data centers. We've talked about some of the features that are in as examples that are in the products themselves and the bits and pieces that we put in the data centers. So now let's talk about how you might utilize these in such a way to minimize your downtime and minimize your data loss. Of course, easiest is to, well, we'll talk about it. Your backup and restore is where you're sitting here on premise or any data center anywhere in the world, and then you just keep your move stuff to your object store and have different buckets for different things, different locations, and that's it, right? But then you have to rebuild everything, and which you can do with Terraform, but it could take a couple of hours depending upon how complex you're working with. The other choice is a standby architecture. I call it a ghost town. And basically now you can have the in, basic infrastructure in place. You have copies of some of your stuff, the most important stuff. You have your backup of your block storage and your database are fairly up to date, at least in one availability domain over here, so that if you fail over, you while you're perhaps running at less capacity, you still have good response, not perfect response. And then you slowly build out what else is required based upon. And it's not that slow. It's with your how fast your software can run. It's the speed of software and availability of systems. And then your active architecture, you basically have duplicates, both on premise or in one data center, and then in another, not data center, but in one region, and then across regions, you have duplicated everything. It's already there's should be almost no failure over. And the other way you can work with this and using our DNS and our traffic manager for regional load balancers, you can think about this in the sense of, okay, in Frankfurt you can have a full up system, and in London you can have a full up system, and based upon your DNS structure, your Europeans hit the Frankfurt system, your folks in the UK and Iceland hit the London system, and that works great. And then when there's a failover, everybody goes to Frankfurt or everybody goes to London, and you only keep half of your hardware up because your load balancers, your respective load balancers, keep your background systems up and running, but don't overburden it. So you'd be a little performance lag here, but when failures, but a performance lag, but without any data loss. And you could reconstruct it much faster in that kind of circumstance. But just think about, you don't have to have complete duplication everywhere. I'm an academic, right? So I've never had to set one of these things up where it actually failed. Along those lines, though, I have worked with people that have, and I would suggest you practice stuff. Uh, Make sure you do this more than when you need to do it, right? So part of this is using infrastructure as code. So the idea is what can you do in software beforehand, and can you keep as a structure, as a journal, so that you're in a really good position to build out when you need to. So command line interface is one of the ways. It's probably the most straightforward way, but at the same time, you could build a bash script, or this is a great tool to learn the API calls, because you can go through this, practice it, build simple little scripts, and then based on that, use the language of your choice, Python, Java, Ruby, to then make the calls through the SDKs. And they're all REST API calls. So and in fact, for the CLI, you're running on a Python SDK. Resource manager, this is probably key to your success. And the number one reason is it runs on the standard Terraform open version at this point, and I think we're up to 1.5. So the idea is the resource manager, though, as you might imagine, Oracle has very large customers scattered and shattered all over the world, as likewise their administrators are scattered and shattered all over the world. So we want to make sure that people don't step on each other. And the resource manager, at the simplest version of thinking about it, is a queuing system for Terraform. It keeps people, as long as they use it, from stepping on each other and through the process. And also, yeah, this made a nice slide 10 years ago, compute, storage, and network. Anything that is in our cloud can be any product, any service can be created in a Terraform file. So this is not limited to the basics. And this is just what Terraform looks like. It's a standard, goes to the compartments, you get software, it hits our API service, and it's just a translator for API service. The reason why we love it is, and we suggest it, is because you can take it and with very few changes, you can run it anywhere else on any other hyper cloud provider as well. So this is not wasted knowledge of your time to spend time learning Terraform. And might also want to think about Ansible. That's another choice that you can make, though for the most part, while you can create the overall architecture in Ansible, we suggest you use Terraform and then Ansible as something that you might look to build out a particular set of containers or virtual machines in that respect for an application as opposed to the infrastructure itself. So key to this is not only it being a queuing system, but we also have the ability to do update your stack as well. And when you do that, it finds out what you really have, because at the end of the day, we didn't want to prevent anybody from running Terraform as it is without using Resource Manager. If you've done it before and you're happy with the way it runs, you can put a producer in OCI for OCI and it will work. But and you can do things in Ansible as well. But it's always good if you are using Terraform to maybe get an update your stack to see what you really have versus what you think you have, and it also doesn't keep people from running the UI or a Python code to create code using the or OCI. So any of these things. So you need to understand really where you are. And then you can, after you check the execution plan, review it, you can then apply run and see what it looks like, see the errors, see where somebody had messed you up, and then you can put this together. So and then you can destroy the stack. This is good because you can it goes through winding up as well. So it gives you a good capability of winding things up. For example, if you want to shut down a virtual cloud network, first you have to take out all the routes tables. You have to take out all the different tools that are in there, all the subnets, and then you can shut down the virtual cloud network. So the other thing that we developed here in the last year is this CD3. It's Cloud Deployment Design Deliverable. Uh, anyway, we have those big customers. Some of them have been keeping track of their systems for a long time in spreadsheet type journaling. So what we basically wrote was a wrapper around Excel that then creates Terraform, and it works both ways. So if you like Excel, then you can run it through, create a template. This CD automation toolkit works in Jenkins. You can then use Terraform and create the Terraform and go back and forth. So you can work with whatever tool you're comfortable with. Clearly, a big customer wanted that. So communications on premise and around, you have your dynamic routing gateway. You can use it to establish your connection on premise, IPsec VPN, and Fast Connect, which is probably for larger customers a more likely manner at this point. Though VPN is a low cost, secure manner to get there, depending upon your ISP and the number of threads you allow for it. So the other thing is, of course, you can have multiple. Um, you want to reduce your dependency on a single route, so you can have multiple routers. That's what we call CPE, customer premise equipment, and that you have multiple routers instead of just having one come into our point of presence, and then it gives you the capability. Of note, if you're using this IPv6, then we take over encryption at this point. You use your encryption to get to our router at the edge, but and then you have your key that we provided you on entrance. Fast Connect, this is probably where most people are now, simply because 1 gig to 10 gigabit increments can be very fast, and extend your private peering to connect to public resources versus public peering. Again, using those DRGs. And just what is it? It's a software wrapper around your router. Uh, no charges if you're using Fast Connect for inbound or outbound data transfer. That can be appealing depending upon your requirements. And everything uses BGP protocol. Again, just another diagram shows you again the same thing. You can have this as redundant as well. You're not limited to a single piece. It's a cost with respect to your local ISP, but that too is your choice. And as I spoke about it, there's the slide. Not seeing very many questions. We invited Jason to be here to answer those questions, so be sure to.
Then one thing, to go back to that last slide, I find interesting as customers are figuring out whatever their disaster recovery is, the idea that I want to fail over to another region is looking at that network topology. What you need in your production environment might look like a couple of 10 gig fast connects because maybe you have a lot of data, maybe you've got it set up for redundancy and failover. What you might need in your DR site could be less than that. And it kind of goes back what Lynn was talking about earlier in the deck here is figuring out the expectations of your customers internally, how fast they expect you to recover their databases, to recover their applications, they can do business as normal. Oftentimes we'll give you some guidance architecturally on, do I need two 10 gig fast connects in prod and two 10 gig fast connects in my DR site? Or can I get away with a VPN? For the first day or so, will a VPN be enough to get me up and going as I'm recovering applications? And this is where you've got some design decisions and where we've got some different tools you can use to meet those kind of outcomes. And so as you're thinking about like foundationally, what do I need to pull this off? We had a good question earlier on things around active data guard in region or data guard. That is really a good foundational thing to think about at a database layer. But you also want to work with your networking team to understand, what do I have at an infrastructure layer to, again, meet the expectations of my customers, and what kind of network, bandwidth do I need, network tools do I need for high availability and disaster recovery in another region. So these are all kind of like your Lego building blocks to make sure that as you're building up your DR, you've got your data replicating and you've got your network there ahead. Your network is done and built before a bad event happens.
Thank you, Jason. And as I mentioned before, one of the key elements is your DNS zone management so that you can fail from one region to another almost instantaneously. And the other tool that this gives us is your traffic management with your steering policies. Now, I like to remind folks that we have our steering policies based upon the tools that we have. You're not limited to those. If you want to put a router of your similar to what you're currently using software wise, where you maybe have a couple of thousand policies that are in place for specific customers to hit specific servers under specific circumstances, then those are probably in our marketplace for you to look at to make sense of in those circumstances. So you're not limited by our load balancer and traffic management systems. So likewise, I was mentioning your primary versus your redundant and your failover from A to B. So this is just a visualization of what I just talked about. Now, the other thing I do, well, before I do that, I do want to um, mention, I'll do it here, that as I said before, you want to practice this. I worked for other companies over the years, and I've worked for three-letter agencies, and I started out life um, running out of never mind. I was a B-52 pilot back in the day. And so we practiced disaster recovery and creating disasters at a worldwide level every week. So we got really good at it, practicing it, that is. And so when we did actually have something happen, we didn't make mistakes. And that's what I would remind you of. You have to practice this out. And you see the major companies that work with us, folks, I guess I shouldn't mention any names, but the folks that you would think would work with Oracle and that do have a global presence and that would want to look at full stack recovery, that they practice this and they practice the checklist and everything else. Because the worst you want to have happen is you want to have a newbie for your real disaster recovery that's never run through the checklist before. That will cause a problem. So with us, now we are giving you this full stack recovery capability. And of course, the reason why is because customers came to us and they wanted it, and they wanted a single pane of glass. They didn't want to go through all this themselves. They wanted to be able to do the disaster recovery at scale. They want it simple to execute. They wanted to make sure we were using the best practices in every way at all the time. So you validate it, the DR before it is needed. And that's sort of the lead in what I was saying. You're able to run through it, and then you still better practice it. So it's another nice slide on this. So you build your DR run books, can be built in minutes. You customize the run books to suit you. You validate before it's needed. Gives you the opportunity to do disaster recovery at scale. You capitalize on existing efforts that you might have done elsewhere, and you use any DR topology that you want. This is customizable. You come to us, we'll work with you, and you can put it together. You can let us do it all, or you can make sure that you want and understand every aspect of it. And so we'll give you some references.
And one thing, Glenn, if I might add in there, because I kind of like drawing it back to the question earlier, full stack disaster recovery doesn't replace what you do at a database level, say like a data guard, setup where you could have an active or an active passive. It doesn't replace the replication. It doesn't replace the internal failover of the database. It doesn't replace what you might do with replication for object storage or file storage. Where it operates at is taking those tools like data guard, like object store replication, and orchestrating the failover events, not the actual replication. So, in the earlier question, the question was, could I set up a data guard between two databases within a region? Or you could do it in both regions, of course. Where full stack disaster recovery come in, it would take kind of the job of what a DBA would have to do during a DR event. It would tell the database to fail over. It would tell the object storage to stop replicating maybe the backups. It would build servers that you have. So it basically comes in and automates all the tasks that you would have to do, and it works with the toys and tools to replicate data and to bring services up. And what we've seen in the field of many customers is, really good DR plans by customers can be executed on premise or in the cloud in an hour. That's pretty common. When we bring in automation, like we can do with full stack disaster recovery, we can get it done in minutes. 10, 15, 20 minutes is something we commonly see out in the field with taking what you have today, automating the toys we let you play with, like Data Guard and the different replication tools, and basically automating that into one playbook.
And if I might also add to that, Jason, that one of the things that I find useful in thinking about this and would recommend as customers you think about it is even if you don't want to use our full stack recovery, but if you're thinking about any level of disaster recovery in your business, that you walk through the documentation that we have. So this gives you right up here in our under our documentation full stack disaster recovery. You go to that page, you look at the prerequisites, you can find there's a checklist to go through later on in this process. So this gives you a lot of things for your team to think about before they ever really deploy in this circumstance. So it's another concept of how to help you by reading the documentation, by understanding what we're going to do for you and how you can do it for yourself or be better prepared to work with us to make sure that you're successful in what you're doing in these circumstances. Non-disruptive DR drills. Using a single button. You really do need to, sorry to overemphasize that, but to Olivia to actually show you some stuff.
But for this demo, I'll be walking you through FSDR, or full stack disaster recovery, and how to get started. And essentially what I'm showing today is based off our live lab, so we can send over the link for this at the end if you kind of want to take a look or explore this a little bit more. But yeah, I'm going to show how FSDR will help to orchestrate DR switchover for our cloud native MuShop application right here that is deployed in OCI across 2 regions. So for my case or my example, I'm using Ashburn here as the primary region, and then you'll see me switch to this tab right here where I have Phoenix as my standby region. But yeah, to get started, what I did is I created a custom image, and then I also used Resource Manager to provision my infrastructure. So Lynn kind of discussed that earlier. It's an easy way to automate that process. But yeah, to get started, I went to compute. I created a custom image. So you can see my MuShop image right here. And I also need this because for my resource manager stack, I included this OCID value or Oracle Cloud Identifier into my compute Terraform file. So that's one of the steps that you need to do in this example here. And then to actually provision the infrastructure, I went to developer services. And then here you can see resource manager. And this is a great page for getting started. If you kind of want to get an idea for this tool, some templates, some tutorials, what's new, some examples here, and some videos. So what I did is I created a stack. I had my own stack, so I uploaded it here, the zip file, gave it a name. You can specify the Terraform version right here, go to next if everything looks good. And then what I first did for my infrastructure for my MuShop application is you want to run first a plan job just to make sure that, everything looks good to go. This is the changes or the infrastructure that you want to provision. So you can check this in the logs for your job that Terraform has been initialized and that Terraform will perform the following actions. So you can see the changes that it will make. So you can review everything, usually a good idea to do all this. And then I actually need to make some changes to my stack to include the OCID value of that custom image that I created. So you can actually do that with code editor right here. So that's one way of editing your stack. You can also launch it from here. And so, yeah, I launched it, code editor. You can navigate to your stack, and then I just changed the compute Terraform file to include that OCID value. And the nice thing right here is that you can save those changes for that stack. You can save those changes and run planned action. Once again, usually you want to run a planned job before making any changes just to see that everything looks good to go. And you can also save changes and run that apply job, which will actually go ahead and make those changes. And you can also download the stack right here. So just want to point that out. If you want to make changes that way, you can go ahead and do so. And then two, if you ever get errors, which as you can see, I have, it's pretty good about, letting you know why maybe you have an error. So you can view that right here and then make the necessary changes as needed. And then, yeah, we have apply succeeded. So you can review the logs for that as well, just to check everything. If you want to check any outputs, you can right here. But that's how I provision the infrastructure. It's kind of more of an automated way of going about that. And then you can also track the state of that with your state file. But that's kind of a high level overview of Resource Manager and how I got started there. Before I move on to the next step, kind of more for preparing your environment, Lynn or Jason, do you want to add anything that I might have missed?
Yeah, one of the tools that got mentioned earlier in our session today was CD3. And so one of the challenges I run into with customers out in the field is I've got an existing production environment. I need to replicate the network, the security rules that I've got, security lists I've got set up, kind of that underlying plumbing and infrastructure. How can I do that? Right. And definitely what Olivia is showing here is ultimately probably the best way of doing this is assuming that your production was rolled out using Terraform, using templates to deploy it all. This is you take those same templates and roll it out into your DR environment as well, right? Change some names and variables, and you've got a perfect scaffolding for setting up DR. But I also run into customers that when they built their production environments, everything wasn't done with scripts, or it's a hodgepodge. If things were done with scripts, things weren't, and they're not really sure how to do DR. That CD3 tool can be a great asset in basically kind of taking a snapshot of your existing environment and helping accelerate the build out of your Terraform code so that you can build a DR environment that looks, like for like what you've got for production. And so there's two different ways to do this. Hopefully, your environments were built with, good automation, infrastructure as code as templates. If you didn't inherit one of those environments or for whatever reason you just didn't start that way, you might also look at the CD3 tool to help you figure out how can I build a DR environment that looks like prod and works like prod in the middle of a disaster.
And I think we might actually have a live labs for that. I will need to double check, but I'm a major advocate for live labs. It's a great way of getting more experience with some of these tools. So you might want to check that out here as well. We also do have labs for getting started with Resource Manager, all of that. So yeah, that is Resource Manager and provisioning your infrastructure. Another step that I ran through is Cloud Shell. So kind of the web terminal in the console, you can launch it right here. And what I did right here is I downloaded the autonomous database wallets that I created from Resource Manager using Cloud Shell right here. And then I just transferred the wallets to the application VM instances. A few other steps I ran through was I connected to the application VM instances and executed the application change script. So those are some of the steps I ran through right here, but you can see some of that wallet information here. So Cloud Shell is another neat tool to leverage. And then yeah, so from there, going back to the home page, where I'm mainly going to be working is migration and disaster recovery and creating my DR protection group. It's essentially a resource type used by FSDR. It's a collection of different OCI resources that comprise an application that may consist of your instances or your application servers, your block storage, databases, all of that. So you can create your DR protection group. So I already went ahead and created this so we can see ushop Ashburn 1. I've already ran through the steps so we can see this is active and this is our primary. And then I've also set it up to where Phoenix is the peer DR protection group. So you can see the peer region. But yeah, otherwise you can go ahead and create that here and then select the object storage bucket, which is something else that was created in the resource manager apply job, the role. So you can specify this as primary if you want that, or not configured. So yeah, I already created that right here. And then from here, you can add some of the members, which I've already done for some of my different resources. So my load balancer, volume groups, compute instances, my autonomous database. So you can go ahead and add that here. So you can select the resource type. So if you're doing like autonomous database, you have to click that, understand that you must refresh and verify all the existing plans. So you need to check that off. Select the autonomous database and then the standby type for DR drill. And then you can go ahead and add that. It may take a moment to update. And then, yeah, you can do that for your other resources, compute, your load balancer, OKE cluster. So you can add all of these here. So I did that for my Ashburn region, and then switching over into my Phoenix region right here, going to migration and DR, and then DR protection group, which I've created right here. So we can see that this is our standby and that our peer region is Ashburn. And then you can add some members here too. So I just have load balancer and my autonomous database. So we don't need to add compute and volume groups in this case, as the VMs are defined in cold VM DR pattern. And those VMs will be created automatically using the DR switchover process. So that's why I didn't have that here. But likewise, you can also add the different members or resources right here. And then from there, you can create your DR switchover plan. So if you go to plans right here, I've already created one, but if you want to create that plan, you would give it a name and then specify the plan type. So we did a switchover, so basically shut down at primary and then transition to our standby right here. So you can create that plan. And yeah, so I already have a plan right here that I've created. And then from here, you have some built-in pre-checks right here. So you can see the list of that right here. You can see load balancer, so update, source, back, and set. So you can see all the lists right here. And then you can enable or disable some of these features or groups. So if you want to rename it, disable these steps, you can go ahead and do so. And then you can also add groups. So maybe you might have a group in this case for like restoring your application or something like that. And then you'd specify the group for that. So you can certainly add your own groups, then you can add your own steps. So you can give that step a name. You can run an object storage script. You can run a local script. You can invoke a function. So you can add your own steps in the pre-check. And then you can also reorder this. So if you want to move something down, you can go ahead and do these steps right here. And it's always good to maybe run a pre-check first just to make sure that, everything looks good to go. So you can see that under plan execution. So I just ran one real quick right here. And yeah, you can just check the different steps. If it succeeded and if it failed, you can go right here and you can view the logs if there are any errors, kind of see, what went wrong. But that's your pre-check. And then after that, if you want to perform the switchover, you can go ahead and execute that plan. And then if you just kind of want to test this out for fun, if you're maybe running through the lab, you can go back here, go to your networking. All of these steps right here cover that. So performing the switchover, what that looks like if you want to break your MuShop application and then perform the switchover, you can. So essentially changing one of the ports on the listener, so you can see all the steps here. and then any post switchover tasks. So highly recommend taking a look at this and just the live labs in general. And then another thing to note, as once again, kind of the switchover can take around 20 minutes. If you want to see some of this more in depth, we do have this on Oracle Learning for FSDR, so you can see that there's many different demos to explore right here.
Olivia, thanks for going through that. There's a lot of good stuff. The one thing I think I'd call out to the DBAs that are listening in today, the server admins listening today, is a lot of what FSDR can do for you is those manual tasks you do as a DBA, right? As a DBA during a failover or switchover test, you would go in and perform failover operations, right? FSDR is going to take and configure that for you, where you don't have to create a script. You don't need any Terraform code for at least that portion of your failover. You can basically just configure, here's my source, here's my target, and FSDR behind the scenes will take care of all the DBA tasks you'd have to do if you did that manually. Same with building a server, right? There's a server admin and a failover event. You may have to rebuild a server. You may have to recover a server. FSDR is going to come in and automate that work. So pretty much anything, if it's an Oracle API, it's an Oracle action, think of FSDR as a tool to come and do that work for you without any scripting. And there's probably some use cases where you have scripts for your applications that you also need to run. When the app's up and the database is up, maybe today you have a recovery script, and that's how you make your environment whole. FSDR can run those custom scripts as well. And you can build that plan, as Olivia was going through, that runs the things that we do to orchestrate all the APIs, the failovers, the building the servers. And in the middle of that, you can also put your own custom scripts wherever they need to be, so that when your environment is recovered, it's recovered whole, it's recovered working, and it's recovered to the point where it's the least amount of work for you to be able to put the whole plan together from start to end. Your account team, right? That's kind of the group I come from. For those that have seen something interesting today, whether it's CD3 or it's FSDR or one of the replication tools, look at the links Olivier and Lynn have got out there. But at the same time, this is a good opportunity to come pick on your account team and say, show me more. I'd like to see a demo. I'd like to do a POC. I'd like to get some hands-on assistance. There's a wealth of resources we have to support you in making sure that these tools that you're using, you're interested in, that you have a good experience with them, that we accelerate how quickly we can get them in your environment and get you up and running.
Definitely. And to add to that, in this PowerPoint, we do have some of the links here for live labs and some of the other programs I highly recommend exploring. And then we do have this Day One and Beyond series right here, where it's more one-to-many. But we also do have personal training on a variety of different topics. So it's more one-on-one customized training. We also do have live labs. So if you want more hands-on experience, that is an offering. We also do have Code Innovate, so it's a 5 half-day online event where Oracle engineers will help you co-develop a use case. So if you're interested in these, we did link the emails here to reach out. And then lastly, we have this core series here, but we also do have hands-on, cloud native, cloud security, all of that. So please feel free to explore those. And then, yeah, our next session will be Oracle Cloud Security on April 15th. So we'll cover some of the different security tools and services in OCI and some best practices. So we hope to see you all then.